Hello friends, welcome back to my YouTube channel. This is part number 5 of my discussion on leaching, and I will continue discussing stage-wise leaching. In part number 4, I had discussed the theoretical concepts of single stage leaching, and now based on those concepts, I will be solving one numerical in today's lecture. So the objective is to discuss a numerical that is based on single stage leaching. So let us start the discussion. First of all, we will look at the numerical statement. Vegetable oil seeds containing 100 gram insoluble solids and 10 gram oil are contacted with 200 gram of fresh organic solvent in a single stage leaching operation. Determine the amount of oil left in the oil seeds after leaching. The equilibrium relationship is given by the following equation. Capital N is equal to minus 4y plus 8. In this case, capital N is gram of insoluble solids per gram of solvent plus gram of oil in the seed phase. Small y is gram of oil per gram of solvent plus gram of oil in the seed phase, and x is gram of oil per gram of solvent plus gram of oil in the solvent phase. So you have an equilibrium relationship that relates capital N to small y, and capital N, small y and small x, they are defined in this ways. Now seed phase in this case is the underflow. What is the meaning of seed phase? Seed phase is nothing but the underflow, and solvent phase is nothing but the overflow. So you have one simple equilibrium relationship that is given to us. The tie line data is also given, that is various values of x, and then the values in equilibrium with those x values. Y values are also given to us. So these are various values, equilibrium values. So this pair is in equilibrium with each other. This value of x is in equilibrium with this value of y. Simple 4-point data is given to us, and we are going to use it to solve the numerical. So the feed is 100 gram of insolubles. Feed, it contains mixture of insoluble solids and oil, which is to be recovered in a single stage leaching operation. So in this case, the feed is 100 gram insoluble solids plus 10 gram oil, and this is contacted with 200 gram of fresh organic solvent in a single stage leaching operation. And after the end of the operation, we are supposed to find out the amount of oil left in oil seeds after leaching. And you have the equilibrium relationship. I have just discussed it. So the operation is, you have, let us understand it. So you have vegetable seeds. Let me show this. And this is contacted with organic solvent in a single stage operation. And what is happening? Oil from this oil seeds is getting dissolved in the solvent, and you get the overflow or the clear solution, and this clear solution is then removed. So we are supposed to find out what is the quantity of oil that remains in the leach solids, or what is the quantity of oil that remains in the underflow, which in this case is the seed phase. Seed phase is nothing but the underflow. So our aim is, out of 10 gram of oil that is present in the feed mixture, how much oil is left in the seed phase, in the vegetable seeds, because the remaining quantity of oil is going to get dissolved in the solvent and it will be removed. It is going to get dissolved in the solvent and some oil will be left in the seed or in the vegetable seeds, and we have to find out that quantity of oil left in the vegetable seeds. And you have the equilibrium relationship that is given to us. The tie line data is given to us. With this information, let us solve this numerical. Okay, so first we will list the data that is given to us. The components involved, you have A. As per our notation, A is the solvent that is used in leaching, and in this case it is the organic solvent, an organic solvent. Then B, it represents the insoluble solid that is present in the system, and in this case we have oil-free vegetable seeds. So this is the insoluble solid. Then C is the solute that is to be recovered by using the leaching operation, and in this case the solute is the vegetable oil that is present in those vegetable seeds. So that is solute in this case. Then feed, it is vegetable seeds containing oil in it. So B, which represents the mass of insoluble solid that is present in the feed, and it is, in this case, it is 100 gram. So B is 100 gram and it remains unchanged. So 100 grams of insoluble solids will enter the operation and 100 grams of insoluble solids will come out of the operation. Then C, the mass of solute in the feed, it is 10 gram that is given to us. A is 0. There is no solvent present in the feed mixture. Therefore, A is 0. The solvent is fresh organic solvent. That means it contains A, and amount of A in it is 200 gram. Sorry, amount of A in it is 200 gram. B is 0. The fresh organic solvent is not containing any solid in it. So B is 0. And even C is 0. Since you are using fresh organic solvent, there will be no C in it. There will be no insoluble solids in it. If you are using a recovered solvent, then there may be some amount of C in it. But in this particular numerical, we are using fresh organic solvent. That's why there will be no C in it, and there is no any question of insoluble solids present in the organic solvent, present in the solvent. So in the solvent, you have A 200 gram, B is 0 and C is 0. Then we are supposed to use single stage leaching. Equation for N is given. Tie line data is given to us. That means we have been provided with various X and Y values that are in equilibrium with each other. And what are we supposed to find? We have to find out the amount of oil left in the vegetable seeds after the leaching is completed. We have to report the amount of oil that is left in the seeds after leaching is completed. So with this data, with this given data, let us solve the numerical. First step is we are going to find out these quantities. We are going to find out F, we are going to find out S0, small yf and nf. These are the notations. In order to understand these notations, you please watch my earlier video, Leaching part number 4, where I have discussed the theoretical aspects of single stage leaching. I am giving link to the entire playlist on leaching in the description section. You please watch all the relevant videos. So first step is we are going to find out F, S0, YF and NF. So how to calculate capital F, F is nothing but gram of A plus gram of C in the feed. Simple. It is mass of A plus mass of C that is present in the feed. And we know gram of A in the feed it is 0 and gram of C in the feed it is 10 gram. So we just have to use these values to get F. So F will be equal to 0 plus 10, that is F is equal to 10 gram. That in this way we get F. Now let us calculate S naught. S naught is gram of A plus gram of C in the solvent phase. And gram of A in the solvent phase it is 200 and there is no C in it, so gram of C is 0. Therefore, S naught will be equal to 200 plus 0, that is S naught is equal to 200 gram. Then, how to calculate YF? For that, we need to know how it is defined. So, small YF is gram of C per gram of A plus gram of C in the feed. And all these quantities are known to us. Therefore, YF will be equal to gram of C in the feed is 10 divided by gram of A in the feed is 0. Gram of C in the feed is 10. So, this will be 10 upon 0 plus 10. That is YF is 10 upon 10. That is YF is equal to 1. Now, let us calculate NM. So, NF it is defined as gram of B per gram of A plus gram of C in the feed. So, therefore, in the feed we know gram of B is 100. B is 100 gram in the feed. So, therefore, NF will be equal to 100 divided by 0 plus 10. That is NF will be equal to 100 by 10. That is NF is equal to 10. So, in this way, we get all the 4 quantities that we will need in our calculations. First, we have got F 10 gram. Then we got S naught, it is 200 gram. Then we got YF, it is 1. And then finally, we got NF, which is 10. Let us move ahead. So, after getting the values of F, S naught, YF and NF, now next step is we have to plot the required graphs. So, one graph is X versus NX and Y versus NY. This both will be plotted on a single graph. So, NX and NY, they are plotted on the y-axis. X and Y, they are plotted on the x-axis. Then we will need another graph, which is X versus Y graph. So, that also we are going to plot. So, in this case, small x is plotted on the x-axis and small y is plotted on the y-axis. Now, X and Y, that is tie line data is given to us. N is given to us, but it is given as a function of y. We have this equation. So, since it is depending on y, this N is nothing but Ny. So, Ny is equal to minus 4y plus 8. That means for every value of y that is given to us, we can calculate the corresponding value of Ny. So, this is Ny. Then different values of Ny then can be obtained by using the given values of y I have just told you. Capital N is not a function of x. That means N is not depending on x, which suggests that Nx corresponding to the given values of x, they are equal to 0. So, every Nx that corresponds to the given value of x, it is 0. So, all Nx are 0. The meaning is simple. The equilibrium data, we will be using the equilibrium data to get Ny and Nx. Nx, as I said, all Nx are 0. So, you have x and y values. I will just write all the given values. And then by using this equation, I will find out corresponding values of Ny. So, for every value of y, there will be one value of Ny. So, if you use this equation, you will be getting various values of Ny. So, 6.96, 6.88, 6.76, 6.64 and all Nx are 0. Nx is 0. So now our task is we are going to plot nx versus x and ny versus y on the same graph. For example, for your understanding, I have shown calculations for the first entry. First value of y is 0.26. So in that case, ny will be equal to minus 4 into 0.26 plus 8, which comes out to be 6.96. And all nx is equal to 0. What is the meaning? The meaning is the overflow does not contain any solids in it. If nx is 0, that means overflow does not contain any solid in it. And in that case, this x versus nx curve, it will correspond to the x-axis because all nx are 0. I hope you are understanding the concept. Okay, now let us move ahead. Okay, x versus nx curve, it coincides with the x-axis, I just told you. Now, let us first plot the two graphs. First graph is we are going to plot xy versus nx and ny. Xy, they are plotted on the x-axis, and nx and ny, they are plotted on the x-axis, on the y-axis. Sorry, nx is plotted against x, ny is plotted against y. So you get this curves. So this is yet y versus ny curve, and this is x versus nx curve. And since all nx are 0, you can easily see, or it is clear that the curve is coinciding with the x-axis. And then for our use, I will be connecting those equilibrium values, equilibrium concentrations, equilibrium x and y values with these tie lines. So these are all tie lines, 4 tie lines. Then we also need a y versus x graph. So in this case, x is plotted on the x-axis, y is plotted on the y-axis, and you get a curve like this. So this graph will be useful for us in order to draw the required tie line. You will come to know. Okay, so once two graphs are ready with us, let us proceed further. Now first is we will locate point F. Where is this point located? This point is located at YF NF. And YF, we know it is 1, NF it is 10. So on this graph, F will be located over here. So for this point, YF is 1 and NF is 10. So point F, it will be located over here. So after locating point F, we have to locate point S0. And point S0, it will be located at X0, N0. And since solvent is fresh, X0 is 0. So in that case, the other thing is solvent does not contain any solid. So N0 is also 0, which means that point S0 will be located at the origin, 0, 0. So point S0 will be located over here. So once you locate point F and then you locate point S0, the next task is we have to connect F0 with S0 with a straight line. We have to connect F with S0 with a straight line. So this will be the required straight line. F is connected with S0 with a straight line. And let us know it. Okay, now next is we have to locate point M1. It will be located on the line F S0. And what are the coordinates of point M1? They are YM1 and NM1. We have to find both of them by using the equations. NM1, it is given as B, mass of B divided by F plus S0. In this case, B is 100 gram, that is known to us. F, we calculated it earlier, it is 10 gram. S0, again we calculated it earlier, it is 200 gram. So therefore, NM1 will be equal to 100 divided by 10 plus 200, which gives us nm1 as 0.48. Now we are going to use this. You please note either one of these two, ym1 or nm1, can be used to locate the point m1. So here I am showing how to use nm1 for locating the point m1. So we get nm1 as 0.48. Now we have to locate it. So what are we going to do? We are going to locate 0.48 on the y-axis, and after locating that, I'm going to the line fs0, and where the intersection occurs, that is nothing but point m1. So in this case, point m1 is located at the intersection of line fs0 with the y coordinate, which is equal to nm1, that is 0.48. So this is how you can locate point m1, or you have to locate point m1. Okay, now the important task of drawing the required tie line. So for that, we can use a simple approach. First, you draw a tie line through point m1 that is parallel to the nearest given tie line. And once you draw it, let me show it over here. So I have this diagram. I have ny versus y curve, and then nx versus x curve is coinciding with the x-axis. Now, let me tell you how to draw the desired tie line. So, as I said, draw the tie line passing through point m1 that is parallel to the nearest given tie line. For example, let us say that this tie line is the tie line that I draw through m1, and that is parallel to the nearest given tie line. Let us say that this is the tie line. Now next, what I will do, I will read the x coordinate of the lower end of this tie line. X coordinate of the lower end of the tie line is the x value. So let this x value is a. Now the tie line that I have drawn in this way, it may not be the correct tie line. So what I have to do, with this value of x is equal to a, I will come to the equilibrium diagram, locate a on the x-axis, because this is a is x value. Then I will go to the curve and then get the corresponding y value. Get the y value that is in equilibrium with x is equal to a, and let this be y is equal to b. That is, x is equal to a is in equilibrium with y is equal to b. So once this b is known to me, I will have to locate that b on the upper curve, ny versus y curve. Let us say if b comes over here, so my desired tie line is not the red one which I had drawn earlier, parallel to the nearest given tie line. The desired tie line would be actually a b. So now I'm moving, or I'm adjusting the tie line that I had drawn earlier, and I'm getting this blue color tie line which is passing through m1, which has endpoints that are in equilibrium with each other, and therefore that will be the desired tie line. So in this way, you have to draw the desired tie line. Now let me show you how I do it for the present calculations. So I'll rub this because I have to show the other coordinates. Now, when I draw a tie line parallel to m1 and read its x coordinate, then I get x is equal to 0.03. I have done that exercise. So when I draw a line through m1 that is parallel to nearest given tie line and read the x coordinate of the lower end, which is small x, I get 0.03. So now I have to find out y value of the y value that is in equilibrium with 0.03. So I'll go to the curve and get the y value. And in this case, y value comes out to be 0.27. So 0.27 is in equilibrium with 0.03. So I will take this 0.27, come to the upper curve and look at 0.27 on the upper curve. So 0.27 will be located over here. And then I will draw, once the other end of the tie line is known to me, I will draw the tie line, the desired tie line. Okay, so that means the end points of, just a minute, I'll erase it, so that the end points of the tie line which I need, one end is 0.03, that is nothing but x1 is 0.03 and y1 is 0.27. y1 is 0.27. So the objective of doing all this, the objective of drawing the tie line is to get these two values, x1 and y1. So let us move ahead. And then you can read n1s. For reading n1, you can just read the y coordinate of this point, and that n1 comes out to be 6.9. So that is also required in our calculations. So now the last step. Let us go for the final calculations. So first of all, we are going to find out gram of A plus C, gram of A plus gram of C in the underflow. And for that, I will be using the definition of N1. N1 is defined as gram of B per gram of A plus gram of C. That is gram of A plus C in the underflow. N1 I got it after drawing the desired tie line. Gram of B is known to me. What I get from this is gram of A plus C. Gram of A plus gram of C in the underflow. So N1 is 6.69, we just got it. And then B is, N1 is 6.9, B is 100 gram. So if I use this, it will be 6.9 is equal to 100 divided by gram of A plus C in the underflow. That is, gram of A plus C in the underflow will be equal to 100 upon 6.9. That is, gram of A plus C in the underflow comes out to be 14.49. So once you get gram of A plus C in the underflow, now let us find oil left in the seats. And for that, we are going to use, this is the oil left in the seats is nothing but gram of C in the underflow. And for that, we are going to use the definition of Y1. Y1 is defined as gram of C per gram of A plus C in the underflow. Gram of A plus C in the underflow we got in the first step. Gram of C we have to get it. Y1 we had obtained earlier by drawing the desired tie line. So y1 is 0.27. So therefore it will be 0.27 is equal to gram of C in the underflow divided by 14.49. That is, gram of C in the underflow is 0.27 into 14.49, which gives us gram of C in the underflow as 3.12, and that is the final value that we have to report. So in this way, now we have obtained gram of oil left in the underflow. That is, gram of oil left in the vegetable seeds. So now I can report this value. So that is the answer that is required in this numerical. So with this, I end my discussion for this video lecture. I hope you have understood how to do calculations for single stage leaching, and more importantly, you must have understood how to draw the desired tie line. I have discussed, I had explained how to draw the desired tie line in the case of liquid extraction, and here also you need to use the same approach to draw the desired tie line. So with this, I end my discussion for this video lecture. I hope you have understood. If you have any doubts, you please mention them in the comment section. Thanks for watching my video. I hope you are understanding what I'm teaching in my video lectures. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you'll be notified as soon as I upload any new video on my YouTube channel. In my next video, I will be discussing multi-stage cross-current leaching. For now, thank you. Have a nice day. Bye-bye.